Dr. Esther Trufan, and in today's experiment, we are going to explore piezoelectricity. For this experiment, we are going to start with some crystals that we have been growing over the last month. So let's bring in our crystals first. I prepared a Rochelle salt crystal, and after a month of careful and very rigorous oversight, it has grown to a reasonable size. The next thing I'm going to do is extract it. For that, I am going to use a beaker with some water, some paper towels, and a tweezer. This is a really large crystal. So the first thing I'm going to do is transfer it into the beaker with water and then transfer it onto my paper towel. With that, I just want to make sure that my tweezer is clean because I will be extracting additional crystals. This beautiful and large Rochelle salt crystal is ready for our application. Next, I'm going to extract our sugar crystal. I grew the sugar crystal from a raw sugar solution, and I will do the same thing. First, I am going to make sure my tweezer is clean and dry. And then I am going to reach into my raw sugar solution and extract my sugar crystal. Then it will go into the water. And once I give it a solid rinse, it will go onto the paper towel. I want to make sure it doesn't touch the Rochelle salt, so I will put it on the other side of it and just rub it a little bit to make sure it becomes dry. And I want to store it on a dry surface. I have one more crystal that I want to test out today, and that is my alum crystal. It is of reasonable size. I can grow it bigger if I need to. And then I will bring in my clean water, rinse my tweezers, and then extract the alum crystal, place it in the deionized water, rinse it a little bit, and then I bring in some more paper towels and I place my alum crystal on it, rub it dry, and then place it on a dry surface for later use. And with that, I extracted all the crystals that I'm going to test out. If I'm curious, I can also bring in my gemstone collection and I can try testing piezoelectricity on those. So let's set these aside for now. To measure piezoelectricity, we're going to build our setup first. We'll start with a stand. Then we are going to add a clamp to it, and we want to bring it at a reasonable distance from the stand. For today's experiment, I want the clamp to be touching the surface of the stand. So I am going to turn it not in the correct position, which would mean that the clamp is pointing up, but rather it will be pointing down, so there's no interference with the contact between my clamp and the surface. Once I get it to the lowest possible position, I will clamp it in place. That's fairly low. Because I'm measuring piezoelectricity, I need to make sure that there's no contact between the two pieces that are going to hold my crystals together. So I am going to place a piece of paper underneath because paper is not conductive. For today's experiment, I'll be using a piece of black paper just to increase the contrast between my crystal and the surface. And then I will slide this under the clamp. Next, we're going to use some aluminum foil. I'm going to take off a small piece, and I am going to wrap one side of my clamp in aluminum foil. I want to create just one layer if possible, and as I'm sliding it in position, I need to make sure that it does not come in contact with any of the metal pieces of the clamp, that it's only surrounding the silicone sleeves. And then, because we will be connecting it to a voltmeter, we want to make sure that there's a space where we can create the connection between the aluminum foil and our alligator clips. And we're going to repeat the same thing on the other side of our clamp. As we're working on our setup, it is important that the two aluminum foils also don't touch each other because that will create a connection between the two sides, and we want to avoid that. Once we created our two sleeves, we're ready to make the connection to our multimeter. Here I have my multimeter, And I will need some wires and some alligator clips for that. First thing we're going to do is plug in our connections. Once we make our connections, we are going to connect the end of our wires to the aluminum foil that is connected to these silicone sleeves. And I'm using red and black alligator clips to do this. Once we establish contact, we can turn on our multimeter, and we will be using the 1200 millivolt setting. It should be 0 right now. We're very close to it. Next, we're going to place our crystal in the middle to see which of those crystals will generate voltage. And because we're testing piezoelectricity, we will need something to tap it with. So we have a couple of options for tapping tools. There's this pair of tweezers that is made of metal, and we taped it over with paper and plastic to make sure that there is no metal connection with the crystal. We could also use a popsicle stick that is made of wood, which is also non-conductive, or we can use plastic silverware that has a pointy end. Or if all else fails, we can use a plastic ruler. And as long as the tap is reasonably solid, we are going to observe some voltage. So let's get started. Let's begin with our Rochelle salt crystal because that is the largest one of the bunch. We will need to stretch the clamp a little bit to make sure that the Rochelle salt fits neatly between the pieces. Okay. And we can see that our voltage is 0. We may have applied some pressure already, and so that's why we see a little bit more than 0. Next, we tap and we observe any changes in the voltage. So that was a pretty weak tap. That gave us a little bit more voltage in this setting. And that gave us a little bit more. Now, depending on how comfortable you are tapping your crystal, trying not to break it on your first attempt, you may get much larger numbers as the result of your tapping. Just keep track of the numbers that you're getting and observe what is the biggest number and how many times can you hit that largest number in your tapping process. So those are relatively small values. And if we tap it harder, we get larger numbers. Now, if we would like to try the other way around, we can take the crystal, turn it around, hold it tight, and then do the same thing again. Our values are increasing, but I can see that I've been tapping this crystal fairly hard. And now the crystal is breaking, which it happens over time. Hopefully we get a good couple of taps out of it and we are able to record relatively high measurements. So let's take this crystal off, and because a lot of the flakes are on our black paper, let's just slide out with the paper and then set this aside. As we move on to our next crystal, let's bring in a different sheet of paper. And we're going to try this purple sheet with our sugar crystal. We slide it in position, bring our sugar crystal. This is a little smaller than our Rochelle salt, but let's make sure it is snug between the two sides of the clamp. Our voltage is shifting a little bit, and that may be due to the slight compression we're applying to the crystal. Tapping our sugar crystal, the number went up a little bit, and now it's slowly going back down. It is not generating as much voltage as the Rochelle crystal, which is to be expected. And it is fluctuating among the same values again. If we would like to try another side, we certainly can. Just make sure that you're holding it snug between the two aluminum foils, and that keep tapping generously. And here we have, in this direction, a little bit more voltage generated as a process. Once we are done with the sugar crystal, we can take it off and set it aside, and we can do so along with our purple piece of paper. The final crystal we're going to test today is the alum. And remember, not all crystals have to be piezoelectric. If we don't see any change in the voltage that is generated during the testing process, then it is fair to conclude that our crystal just wasn't piezoelectric, and it's time to move on to another material. Here I have a green piece of paper. This one is for the alum. I will fold it in half and slide it under my clamp. Take my alum crystal and then hold it tight among the two sides of the clamp. And then I am ready for my tapping once my voltmeter settles around 0. And now I'm ready to tap. I've been hitting the alum crystal fairly hard, and yet there is no voltage that is being generated as a process. So I can conclude that my alum crystal is not piezoelectric. Could I try some other materials? Absolutely. Whatever we find that we can grow a reasonably sized crystal of, we can test. So what if nature does the crystal growing for us? That's even better. If we have any quartz or quartz-related gems around the house, we can subject them to this kind of testing. Here I have 2 minerals that I found on one of my trips, and I can apply the same treatment to these minerals. I take them, place it between the clamps, and then apply some force. And either I positioned this wrong or my gem is not piezoelectric. And we can keep working on tapping our various crystals and our various materials until we have concluded our testing.